In the last video, we looked at this pattern using 3 as our base, 3 to the 4th, 3 to the 3rd, 3 second, 3 to the 1st, 3 to the 0 power. And we use this pattern to justify that a number raised to 0 ought to be 1. Well, if we continue this pattern by reducing my exponents, 4, 3, 2, 1, 0, now we're going to go to negative 1, aren't we? 3 to the minus 1 is what? Well, again, to jump from this number to the next, we divide by 3. Divide by 3, I get 27. 27 divided by 3 is 9. Divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. So there you have it. Now this, again, this is also a leap, like the 0 exponent. To say that, for example, a number raised to a negative power, to a negative 1 power, is 1 over the number. In other words, it's a reciprocal. This is also by definition, and I don't want to go into all the reasons for it, but we need 2 definitions to make this transition from the natural way of expressing exponents with positive whole numbers into other kinds of expressions with negatives and zeros in order to expand the theorems and come up with a more expansive set of theorems or rules, if you want to think of them as rules. I need 2 definitions. One is x to the 0 is equal to 1 and x to the minus 1 is 1 over x, provided that x is not equal to 0. If it was, then I'd have 1 divided by 0, which hopefully you've learned before. A number divided by 0 is undefined. It's an undefined operation. We can't calculate it. All right, so there's that definition. Now once we have this, it is possible to create a theorem that says that in general, x to the minus n power is 1 over x to the n. 1 over x is not equal to 0. So this happens to be a theorem that we can prove based upon everything else we know. And I think I'll leave it at that. But here's what's I think you observe out of this. When you change an exponent sign, the sign of an exponent from negative to positive, it changes the position of the base in a fraction. So in other words, for example, if I had 2 to the minus 4, this would be 1 over 2 to the 4th, which would be 1/16. If I had, you can show this, if I had, for example, 1 over 4 to the minus 2 power, then when I change this exponent, it reverses position in the fraction of the base. So in this case, you can actually argue that this flips the fraction again. The 4 comes upstairs as 4 to the positive 2, which is 16. Again, it's 16. So anyway, the idea is that, and I'm going to take advantage of this in a future section. Actually, in this section, when you change the sign of an exponent, you change the position in the fraction. So we'll exploit that for what it's worth. So let's see. What else can we do here? What is 3 to the minus 2? Well, according to this stuff, this is 1 over 3 squared, which is 1/9. But you can also follow from this pattern. 1/3 divided by 3 is 1/9. Okay, that arithmetic makes it 1/9. So 1/9. This is really great because wouldn't it be bad if 3 to the minus 2 was equal to 1/7? Oh, thank goodness we don't have to learn a whole new arithmetic table, multiplication or division table. All right. Well, let me throw one more example at you here, and let's have a fraction raised to a negative exponent power. Suppose we had 3/4 to the minus 2 power. So, and I erased the theorem, which says that x to the minus n is 1 over x to the n. basically it's like this. When you, again, I want to build on this idea. When you change the exponent from negative to positive, you're changing the position of the number in the fraction, of the base in the fraction. In this case, you can look at it as inverting the fraction. I invert the fraction. So in other words, it's 4/3 to the positive 2 power. It's a little messy to go through that, but here's what it would look like. You know, technically this is 1/3/4 squared, which is 1/9/16, which is 1 divided by 9/16. Invert and multiply is 1 times 16/9, which is 16/9. All right, so technically that's what's going on, but let's be sensible about this. This works too, because 4/3 squared is, guess what, 16/9. So textbooks, I don't think emphasize this well, if at all, that when you change an exponent from negative to positive, you flip the fraction or you reverse the position in a fraction. And I think it's very, very useful to really understand that well. So comparing this to that, I think you'll agree with me on this. Okay. Well, our next video we're going to try to put everything together.